Okay, I think we'll get started. So good afternoon and good morning to everyone. I'm Ian Scare from HiveMQ. Welcome to our webinar about running HiveMQ and Kubernetes. We have a great lineup of speakers today, so I'm sure you're going to enjoy the webinar. Before we get started, I'd like to remind everyone that you can ask questions in the Q&A chat section at the bottom of your screen. So if you have a question, feel free to ask it, and we'll try and get to it at the end of the webinar. This webinar is going to be recorded, and we'll send the recording and the presentation slides to everyone who's registered. Now I'd like to introduce the speakers and get started with the webinar. So Maggie Erber is the HiveMQ product manager who is responsible for the recent launch of the HiveMQ Kubernetes operator. She's going to be joined by Christian Roman, who works at our partner company, inovex. inovex has a lot of experience deploying and running HiveMQ and Kubernetes, so we're very happy to have Christian to join us. And Christian's actually going to do some live demos of how you can deploy HiveMQ on Kubernetes. So without further ado, I'd like to turn it over to Maggie.
Okay, so thank you very much, Ian, for this introduction, and also a welcome from my side to this webinar about how to run HiveMQ on Kubernetes. So first of all, a short slide about what you're going to learn today. So first of all, you will learn, or you will see how to deploy on HiveMQ in any Kubernetes cluster, and how to operate and a reliable and scalable HiveMQ deployment on a Kubernetes cluster. And then, of course, you'll also learn how to take advantages of utilities like Prometheus for monitoring. And of course, you also get to know our HiveMQ Kubernetes operator, which was released in August this year. So it is a pretty new product that we have in the HiveMQ product portfolio. And I'd also like to introduce this new product to you. Okay, so but before we dive into the Kubernetes operator, some infos before. So what are the typical technical IoT challenges that we see during or among our customers? So first of all, okay, scalability. That is something that is in the Internet of Things really a main concern here. Because if you think about an IoT use case, so I think the most known one is a connected car use case here. Then you have millions of devices that you want to connect, and the problem with common enterprise IoT infrastructure is that this infrastructure is not suitable for connecting millions of devices. And that is a typical IoT challenge that we see here. The other thing is instant data delivery. So end users or end customers are really used to have instant user experience. So that means messages. So they're used to that messages are arriving instantly at their end. So we need here really a system that has reliable and instant data transfer, and is or can be used for real-time communication around the globe. And combined with the scalability, that is really a huge problem. And the other thing is that usually, if you think about, for example, your connected car, then all those devices are connected via an unreliable network. So that means you do not have all the time a connection. So internet connection is not everywhere possible and also not stable, especially for our moving devices out there. And that is also something that you have to consider if you want to bring your IoT use case into production, because excellent customer experience is also really key for any production use case out there. And so we know that this is really the these are challenges that we see among all our customers, and that is something that we tackle with HiveMQ. So HiveMQ is our enterprise MQTT broker, and it's more than an MQTT broker. It's also a connectivity and messaging platform. And yeah, HiveMQ itself is based on the standard IoT protocol, so based on MQTT, and here it is really compatible to all the MQTT versions. So not only version 3.1, but also 3.1.1 and version 5. And we have here really all the features inside HiveMQ. And because scalability is such a huge technical challenge that we see out there for the Internet of Things, of course, HiveMQ itself is also possible to scale to more than 10 million always on devices. And if you're interested in this more, we also have a benchmark paper there on our website that explains you what we're doing here with HiveMQ and how you can scale your use case to more than 10 million devices. And so yeah, HiveMQ here is really unique because it faces those challenges and solves them in a unique way. One of our really unique features is the elastic clustering here. So that means that you have, or you can distribute the load between multiple cluster nodes here. And you can also scale them up and down regarding your IoT device traffic that you see and that you have for your use case. And yeah, to have also full visibility into your HiveMQ cluster, we have a built-in observability and traceability so that you can really see what is happening on your cluster. And I'm pretty sure we will also see a little bit of these features later on in the live demonstration. So what are the typical challenges that we see in operating a reliable, scalable, and secure MQTT broker deployment? And so once again, I'd like to start with scalability, because if you start with a use case, then okay, so in the beginning you have a few hundreds devices that you want to connect, and that one is okay. But as your product and your use case grow, you will have more devices that you want to connect to your MQTT broker. So that means more than 1 million, more than 10 million devices. So that means your IoT solution, your MQTT broker, needs to scale to the needs that you have. And even if you think about your use case, for example, the connected car use case here, then you have maybe a time period you have really a big number of devices that are connecting to the broker. And then you have other times where you do not have that big amount of devices that are connecting to the broker. And that means you also need to have a solution that is able to scale up and scale down to accommodate your spikes here. So scalability is really something that you have to think about in operating an MQTT deployment here. So another challenge here is business critical operations. So that means it is really key that the IoT solution that you're using is available 24/7. So there should be no downtime. You should be always knowing what is happening on the broker itself. So you also need a team that is available for you and has the continuous monitoring of the system and can react to failures if something happens. And that is really important to you, that you have the 24/7 operation here for any business critical use case. Then another challenge that we also see is, if you have your IoT solution, your MQTT broker, then you want a solution that is able to run everywhere. And to run everywhere, that means, okay, I have something like on-premise here, or also locally that I want to test, or have on-premise in my in my service here hosted in my office, or I want to go in the cloud here, for example, AWS, Azure, Google Cloud, etc., or also use Kubernetes here for a kind of a self-hosted solution. And also a managed service is in some cases maybe the better way to go. So you see, you need a solution where you can decide where you want to deploy it, and even you can change your deployment way here. So start with on-premise and see, okay, maybe cloud is the better way, and maybe then I go to a managed service or stay here with Kubernetes on the cloud, etc. So deployment agnostic is really a thing to think about in deciding which way to go in operating an MQTT broker. And then, of course, time to market is also something that is important. So if you have your use case set up and running, and you have additional features to add here, then continuous deployment, even and also of the MQTT broker, is important. So really bringing the new features from being finished into production, that is really key to have here a fast and secure way to do this. And here one thing comes into play, and that is Kubernetes, because Kubernetes really supports you in doing this. So Kubernetes here is an open source container orchestration system that helps you automating your deployment and also scaling the deployment and managing all your containerized applications that are managed by Kubernetes here. And Kubernetes really has a mighty feature set, like automated rollouts and also rollbacks if something happens, and also has features like a self-healing feature and load balancing here. So it really helps you in being as fast as possible and as secure as possible. And Kubernetes here uses a declarative description of the desired state you want to have from your whole deployment. And I mean, everyone who has already used Kubernetes and worked with it a little bit knows this moment when you say, oh shit, okay, you said all I need was a YAML file. And we also were once at this moment where it says, okay, good, operating HiveMQ on Kubernetes is possible, but bringing all the best practices we know into that YAML file is not that easy. And so we decided to create a new product, which is the Kubernetes operator. And the HiveMQ Kubernetes operator really has all the best practices we know or we learned from the past 7-8 years in deploying, managing, and operating HiveMQ inside. So it's basically really having a HiveMQ consultant that is managing your HiveMQ cluster deployment inside code. And that helps you to simplify your deployment and management of HiveMQ clusters on any Kubernetes-based platform, because it is also a native integration into the Kubernetes stack, and that was important to us to have here. And with that, I'd like to give over to you, Christian, to show us a little bit about running HiveMQ on Kubernetes using the Kubernetes operator.
All right, gladly. If you let me take over the screen then. Oh. There we go. Hopefully everybody sees my screen now.
Yeah, we can see it.
All right. Yes, let me introduce myself really quick. My name is Christian. I work for inovex. We just recently became a partner for HiveMQ. but we already have been running HiveMQ installations and tuning and fiddling with them. And even on Kubernetes, before it was, I was going to say cool, but before it was as easy as it hopefully becomes with using the operator. So let's dive right in, because I have quite a few things I want to show. And since it's a live demo, you never know what could possibly go wrong. But first of all, let me recap on HiveMQ clustering, in case you haven't run HiveMQ yourself. And then quite bluntly answer the question why you would even consider Kubernetes as a platform to put your HiveMQ installation on, or even other things. And then we dive into the demo, doing a bit of deploying, scaling, monitoring, and a bit of fancy things using maybe potentially Hashicorp Vault. That's the last bit. We get to it. All right, let's dive right in. Recap on the HiveMQ HiveMQ clustering. I just stole that off your website, and even the quote is taken from the HiveMQ website, stating it's from 2016. So that was when Kubernetes was not as current as it is nowadays. It was explained how you could run HiveMQ on the cloud. And I'm not going to dive into that diagram. I just want you to take a glimpse on it, and you see what Maggie just explained. To have a broker consists of having multiple instances of a broker. They somehow talk to each other and form a cluster. In that case, it's masterless, so you can just add a few more nodes. There's no controller and things. And then to kind of get a bit of an abstraction to it, to your clients, you want to have some sort of load balancing. That's the rough idea what you want if you run a HiveMQ cluster installation. All right, so that's kind of the goal that we want to have as an infrastructure paradigm. So why would you use Kubernetes to run HiveMQ? So first of all, as I was explaining, we've been running quite a few projects or HiveMQ clusters for projects we were participating in, and most of the time now when you touch the cloud, you use infrastructure as code. So you use tools like Terraform and the newer, fancier tools to describe your infrastructure. But then all of that is not, it's always cloud specific. It's not something that you can deploy everywhere. Even the very common tools like Terraform and things are cloud specific. You always need to do to adapt. It's not a single deployment target. And then there's no implicit integrations, even though the white papers tell you that everything within a single cloud provider can be integrated with each other. Certainly it takes a lot of glue code to make things talk to each other. And then Kubernetes comes to the rescue, or provides a paradigm being some sort of an abstraction layer for that infrastructure. But then nowadays there's no need to actually run your own Kubernetes cluster. Every big cloud provider, even the smaller ones, they offer a managed service. So you get your Kubernetes cluster managed. So that's not something that you would then, in exchange for being able to use this abstraction, have to deploy yourself. But then let's get to that HiveMQ deployment scenario. I just look at the requirements that is written down in the HiveMQ operator documentation, and all it actually states is that I need a Kubernetes cluster that is running on a cloud provider of my choice. So great. But before we can then use one of those Kubernetes clusters that can happily just get by asking for it, we need to check out the big picture. Maggie already mentioned YAML files. But from all that complexity that Kubernetes has, and that please don't ignore, yes? But I just, since we're talking about the operator, I want to numb it down. The only thing that we're now looking at is we get a managed Kubernetes cluster. So all that complexity that you see is already there. That's provided and managed for. The only thing that we do is throw some YAML files at it and see what it does then, right? In the end, that's the setup we're going to get. So we're not going to go into that diagram of complexity that we're creating, but I want to more get your attention to the lower part of the screen, showing you a bit of that YAML document that's key to having visibility of the HiveMQ operator to spawn the various resources that we need on that Kubernetes cluster instead of managing those individual things yourself, like virtual machines and storage and load balancing and everything. So, all right, let's dive right in. How do we get one of those Kubernetes operators to get HiveMQ onto Kubernetes running? So we take this Kubernetes setup for granted. As I said, we're going to use a managed solution. Certainly, you can use it on-premise. You can roll it yourself. But in our case, we just chose a managed solution. In this case, it's Azure, but it's completely interchangeable. So what HiveMQ provides, or what is provided to get the operator to this very cluster that we're talking about, they provide a Helm chart. So it's a package manager to get those kind of software packages onto a Kubernetes cluster. What it does, it provides the operator itself, which is kind of a controller. Maggie just mentioned it or did a good comparison. It's kind of like an administrator that is just sitting there and waiting for instruction of what to do. There's a few custom resource definitions. That's what we're going to look at quite intensively in the actual demo. And optionally, it provides a Prometheus operator, so the monitoring part, but it's optional, so it's just provided. So what we're going to look at, first of all, we're going to keep it simple. We just want to take it for a spin and want to spawn a single node cluster. So there's no connection to the outside, no authentication, no encryption whatsoever. So what purpose could that be useful for? Certainly, it's not a fully production-ready broker, but it could be used for integration testing. If it's so easy to get one of those single node clusters, they can be used into your integration in your integration stage, and then serve to make sure all your software runs perfectly when you switch it or when you deploy it to production. Mind you, there's, as a side note, to test your software against MQTT or the HiveMQ broker in particular, HiveMQ also provides a special test container, which contains the broker and possibility to do unit tests. So you don't actually need that kind of a single node broker for that case, just mention it. So then the next question we're going to answer, looking at the demo part, is what is actually going on. So we look at the monitoring stack, and Prometheus, the alert manager, and Grafana is like the most common stack you will find. As I said, it's provided by the Chorus Prometheus operator. That is part of that Helm chart that HiveMQ provides, but it's fully optional, right? HiveMQ provides all its metrics in the Prometheus format. It's a metrics endpoint, so you can certainly use your own monitoring stack. All right. So then, if you go further, if we have one of those brokers running, we want to scale it further. So more nodes means more performance, more clients. That's what Maggie said. Running a few nodes or a few small nodes might not be sufficient if you expect quite a lot of clients. So to allow more connections, we're going to add a license to allow HiveMQ to scale up higher. And then certainly we want to expose the MQTT service to the outside world. Otherwise, it makes no sense if we have that broker running on our simple or simply running on that Kubernetes cluster. And then we want encryption. That's something we're going to add, and hopefully it works. And last but not least, we're going to add, I'm trying to show you some integration bits and pieces. And namely, that's going to be Hashicorp Vault that we're going to use. That's for secrets management. We're going to use that for client certificates. So your IoT clients, could be cars, could be anything, temperature sensors. They usually get individual X509 client certificates to authenticate with the broker, so the broker knows what client it is, and if it's granted access to the broker to use it. Mind you, that is in that case it's authentication only, so we only know it's a valid client. There's further things that you can add to get full RBAC, so full role-based access control to manage all sorts of access to the HiveMQ cluster. But let's dive right in. If that is too small or in other cases not readable, just please let me know. It's fine on my screen. So, all right, you should see at the very top, that's just a regular shell. I provided or prepared a few YAML files. Let me give you a glimpse of the simplest one. Maybe you recognize that from the slide I showed when I showed the whole diagram of the infrastructure that we likely gonna spawn up. That is not the simplest, but quite a simple one of those documents that you could use to tell the operator, which is just running as a regular Kubernetes deployment, which you see on the lower part of the screen. So on the lower part of the screen, you see those are called pods. Those are individual applications running on the Kubernetes cluster. And one of them, I just selected it as the HiveMQ operator in that case. So the whole deployment is named operator. So that's why it's saying operator. But that's the actual piece of software waiting for instruction of what to deploy or what to do. All right. This document that I showed you up there, the cluster one, is describing the architecture, the scaling of the HiveMQ cluster or HiveMQ node I want. So I'm going to use kubectl to talk to the Kubernetes API and simply deploy that document and tell the Kubernetes API to hand that over to the operator for it then to make it to a HiveMQ cluster. All right, let's deploy. So what happens now is, you can see in the lower part, we now start to see a new pod, a cluster one being spawned up, which is the first bit of HiveMQ. All right. So if we look at the various resources that Kubernetes manages, we see a single pod and a few services. Services are to abstract away from single instances of something to get a central point of entry to them. So the only thing I did was to deploy or to apply this document to the Kubernetes API. Remember that the YAML file I threw at the API. That's the only thing I did, and the operator did everything else. It created all those objects. All right, we now have a HiveMQ node running, and it says, yeah, it's running. I'm going to switch over to the browser screen. I cheated a bit and I exposed that one bit that HiveMQ has built in. Every node has that. It's called the web UI to the outside, so I can access it. But it's running on every cluster node, and it gives you access to the current state of the HiveMQ cluster. All right. So I connected to that one pod or the one HiveMQ node that I just mentioned. Right? We have one cluster node. All right. But that's all fine and well. We have a single HiveMQ node, and what we could do now is we can see if it actually provides an MQTT service. But it's not exposed to the outside yet. So I'm going to use a port forward. So I asked the Kubernetes server to give me access to that to the applications running, so I can use it from my machine. Right? So I'm kind of accessing it from the inside. So it's not exposed to the outside yet, but we get to that. All right. So we did all right, I have an MQTT client, a command line client. In this case, it's MQTT CLI that HiveMQ provides. And I let it talk to local host. All right. So I connect. There's no error message. I haven't set it to verbose, so it's not going to tell me that something's wrong. And so I'm connected now. It's not complaining, but we can already see that. If we look back at the control center, you see there's one connection, and I can even use that the web UI to give me a list of all the clients, and that's the actual client I'm connected with. So I can. That's already a running cluster. But one client is cool. Maybe let's add another client so we can see it actually works. So I've used another, hold on, small prompt. I'm going to use another instance of the MQTT CLI to just publish a message, right? And there we go. Yeah, it arrived at the subscribing client. So we actually have a single node HiveMQ running with only applying that single YAML document. We haven't set up a configuration file. We haven't done anything but apply that YAML file. But yeah, one cluster node is cool, but maybe up it. Let's go up a notch. I'm gonna apply. Oh, let me show the difference. So I'm not, tell me I'm cheating. If you look at the difference in those two documents I have, I only increased the node count, right? So I'm going to apply that changed document, the cluster document, which has a node count of 2. And as you can see at the low part, there's another pod being started. So the operator got noticed that the definition of my cluster, the cluster 1, has changed, and it started working right away to scale up the cluster. So it's going to take a few seconds, and then hopefully it's going to be a proper HiveMQ cluster. Give it a few seconds. So make sure you can look at the log, see that's the output of the HiveMQ. There we go. Cluster size is 1. Now it's 2. So we already found the partner. And there we go. If we look at the dashboard again, I haven't changed anything. I only increased the number, and then now we have 2 cluster nodes. 2 cluster nodes. I don't know if that's really a beefy deployment, especially with the resources I gave it. But let's see if we can apply a bit of MQTT workload. What I have is a simple tool, a Golang tool that we at inovex wrote to test performance of an MQTT broker. It's not a full test bench, but it applies a bit of traffic to the cluster, runs a few clients and does a few messages, so we can see how the load is going. Should be running. There we go. All right. So as you can see, well, we have lots of connections coming in, and there's lots of messages being published. So it's actually working, but it's not really fun, right? So we have 2 nodes inside one Kubernetes cluster. It's nice, as I said, you can do the integration testing, but it's not really fun. So let's go to stage 2, right? So I have a few more things prepared. I want to scale up, right? So I want to look at what's the difference between the thing I have running now and the new thing. I'm going to increase the node count once again, and I'm going to add a license. As I told you, at a certain point, there's a community edition for HiveMQ. You can have a certain amount of connections, but if you want to use more connections, you just require a license. And the only thing I need to do is use built-in, again, a YAML file, a built-in construct. It's called the config map for Kubernetes, which holds the license as a container. So I'm going to upload that license now. And as you can see in that document, I refer to that config map, the HiveMQ license named config map, which I'm going to do now. Going to apply now. All right, I'm going to scale up again. All right, while that runs, what you can see here is I did a few changes. I changed the config map, which can hold the license or other things, other configuration bits and pieces. And what the operator does, it's going to do a rolling restart of the different HiveMQ nodes, so to make sure everything works. All right, so let's see what else we have that we can do. So as I said, you don't want to just be inside your Kubernetes cluster, have it scale and be an HiveMQ broker there, but you want to expose it to the outside. So and this part, the ports portion of that YAML document allows you to tell the operator which ports or which parts of the service with which options you want the MQTT broker to be reachable from the outside. So what I do here is I'm going to change it to be reachable via a load balancer. So what it does is Kubernetes has an abstraction from the cloud, but it has another controller that then talks to the cloud and gets you a load balancer. So let's check out if that, before we apply that, if that other change, we do a rolling restart. So we're going to log in again. All right, it's already happening. 3 cluster nodes, And yeah, what you can see is the license is already applied. I have an evaluation license, and that's valid for a while, but it's already applied. All right. So we now have a 3-node cluster scaled up, but it's not exposed yet. So I'm gonna just add this green bit, the ports to it, and then see what the operator does. I just configured the cluster. I can, as I said, it's a custom resource. So the Kubernetes API or has learned kind of a new type of resource, which is called a HiveMQ cluster. And I just asked the API to give me the current list of those clusters, and there's my cluster, right? And you can see that it's currently in the status updating. So the operator is working to get the configuration that you want. As Maggie said, it's a declarative approach. So you declare what you want, and the operator and other mechanisms inside Kubernetes, they get right to work to make that happen as best as they can. So we're gonna just wait a few seconds. Just gonna look at the services. Maybe filter that by name. There we go. So we have a load balancer now. With the load balancer, it's now reachable from the outside. All right. So let me see if I can already resolve the DNS name. That's another thing that Kubernetes offers. All those infrastructure management things like managing DNS records or even managing SSL certificates or getting this load balancer, it's all abstracted away. I simply describe it in the YAML document and it's there. Is that the IP I want? Yes, that looks good. That's the IP address I want. That tool I mentioned before, the MQTT stressing tool, since it's exposed to the outside now, when I have an internet connection, I can now hopefully talk to the MQTT instance from the outside, right? So that's kind of the options I can give it. I just tell it to talk to that broker and then throw or simulate 1,000 clients to that broker. It's 3 nodes and has an enterprise license. Let's see what happens. All right. Oh, there we go. Logged out again. Log right back in quickly. There we go. There we go. So now within a few seconds, it's going to ramp up to 1,000. There we go, 1,000 connections, and does all sorts of MQTT traffic. So that looks quite functional. As you see, you get a bit of feedback of what it actually does. So we've been just scaling HiveMQ up to now 3 nodes. We have a proper license, and we have it reachable from the outside. Right. So, but having it reachable from the outside is all nice and well. The problem is it's MQTT in this case is just going to interrupt it. You believe me that this benchmark would run through to 100%. I'm not going to waste your time waiting for the benchmark to finish. Oh, hold on, there we go. So the MQTT service that we have now exposed to the outside, actually to the public internet. So if you would connect to that IP address, you would find an MQTT service completely unprotected. You want to have a layer of encryption, right? So if I look again at the difference that I have between the next stage 3, it's a bit complicated. Just make a few changes to the actual load balancing part. I'm going to use a new TCP port, but more importantly, I added a little snippet here at the top. Added a little snippet, not only referencing a configuration map, but also a secret. A secret in this case contains an SSL certificate that HiveMQ should use to encrypt and authenticate to the clients that connect. That is actually the HiveMQ I want to talk to, and then a bit of configuration snippet I had to add to refer to that SSL certificate. So in this case, you might ask, where do I get the SSL certificate? In my case, I have have Cert Manager, another component that is quite common in the Kubernetes world. Most of the time you see it used for a Let's Encrypt certificate. In this case, I have a private certificate authority that issues certificates. So I have a YAML document, in this case a certificate, that describes the SSL certificate. Oh, hold on, apply. There we go. So I'm going to get an SSL certificate. So next up, I'm going to have a certificate, hopefully. Oh, there we go. All right, it's ready. Now I can use that certificate and then change my HiveMQ deployment to be SSL protected, right? So I only gave it I'm still changing only the YAML definition that is read by the operator, and it now configures the HiveMQ cluster to be using the certificate and being SSL encrypted when I talk to it. Give it a few seconds. There we go. See, the port has changed. It's now 8883, which is the TLS protected MQTT port, and the MQTT service I had exposed to the outside before, I changed back to being internally, just a cluster IP. It's only inside the Kubernetes cluster. For my internal services, that's fine, but for the outside, I want SSL. So that's what I changed. I have two listeners now, one for the inside, one for the outside, one using SSL, and the other one is plain. So just give it a few sec, and then we'll see how that works. So MQTT TLS is my my host name. Again, automated DNS management. The DNS has timeout. That looks good. That's the IP I have. All right. So the same thing we had before. I'm going to subscribe to that broker as I'm using my own PKI. I give it the root certificate that it should use. No. All right. Again, same thing. And yeah, there we go. You can again use it, but now it's SSL encrypted. With the thing we have now is we have a scaled up broker. We have it reachable via load balancer from the public internet, but that's not like really a production grade broker, because how do we make sure we only talk to the clients that we actually want? So we up the whole game again. We add client certificates. As I promised, we make the broker only accept certain clients. So I already have a client certificate here, but let's issue a new one just in case. I have there we go. I have a Hashicorp Vault deployed inside the Kubernetes cluster, which is issuing SSL certificates. Right? That's just a bit of noise, but we can see it just right now. Now it issued a new client certificate to me, and I'm going to now tell the broker that it should trust only those certificates that are issued via my own PKI that I have set up. That could be just be part of your device management. So if you give out devices to people, you enroll them somehow and then give out the client certificates. All right, let's see what the actual difference is, and then we are about done and have quite a few added quite a bit of functionality to a former simple broker. All right, there you go. Yeah. So this is the only bit, again, that I added to the YAML document describing the HiveMQ broker. I now tell it again, this is another secret. I give it the client CA. So that's the Vault CA that I'm using to give out certificates. And I tell HiveMQ that it's required to be, the clients are required to provide a proper client certificate. So that's about it. So I'm just gonna apply that. Client certs. All right. And again, you can always see at the bottom when it gets orange, that it's cycling through. So it's doing a rolling upgrade. There's no downtime. Only the clients on that one broker node are disconnected. The whole cluster still stays healthy. Data is on sessions or the queues are replicated between the different cluster nodes, and the operator makes sure that the configuration is applied node by node. Right. So we just wait a few seconds, and then yeah, we should hopefully see how that works. Just a few seconds, and then I'm gonna. See, it's already working. Yep. All right. Same command I used before. I want to subscribe to that broker, and then maybe, and then subscribe to a topic. But what it tells me is, if I go up, it's a bit long. It's a bad certificate. So the broker is not accepting my connection because I'm not sending a certificate, right? So I'm now required to apply a client certificate, which I'm doing now. If I just a few commands more, the client certificate I created earlier, I'm not providing to the broker, and I can subscribe to that broker again. Let me quickly switch to the control center, and then we. There we go. All right. Are we connected? Oh, it's not me. It's still cycling through. Oh, there we go. All right. Refresh that again. That's me. What you can see now, again, the client status that you can see. Not only am I TLS protected, I also provide a client certificate. The broker validates the client certificate and make sure only clients that provide a client certificate that I issued can connect to that broker. Right? But yeah, if you want to go further, you can always you can always add one layer of protection more. What's missing now is any client that can connect to the broker has to provide a proper certificate, but there's no rights or rules applied to that client. And what's there is there's an extension. It's called the Enterprise Security Extension. In this case, that provides a full role-based access control rule set that I could apply to the HiveMQ cluster to then make use of all those details on the certificate, maybe only grant access to certain topics and things. So I'm just going to ask Ian if it's all right if we still show that, or if we run out of time, because I'd gladly show it if interest is there, or if we should dive into the questions.
Christian, I think we should dive into some of the questions, because we've got some good questions coming in. Yeah. But thank you very much for the presentation. Before we get to the questions, I'm going to start a poll. We have a quick poll that I'd ask people to kind of complete. We'd love to hear your feedback about the webinar. So for the first question, is from Adam, and said, do you plan on supporting patches to other resources other than ports and others that I don't remember now? So Maggie, do you want to take that one?
Sure, I can take Darren, and I think you're talking about the patches and the documentation that we provide here. And yes, of course, as soon as we add new functionality to the Kubernetes operator, we also will update the documentation on our website and also add new patches here.
Great. Christian, from Peter Laurent, can we use HPA as well? Are you able to?
Yeah, that's the horizontal pod autoscaler. So that's a component that is looking at the load of something in Kubernetes and then adjusts the number of instances that are used to work on that on the requests. The horizontal pod autoscaler cannot be used directly because it's a custom resource, but there are autoscalers that can.
Okay, perfect. From Peter Laurent, how about full MTLS? Can we run in a service mesh? Christian, can you take that one? Or?
Yeah, sorry, I just had a phone call that interrupted my my headset Bluetooth connection. Could you just repeat the last question? I gladly answer it.
How about full MTLS? Can we run in a service mesh?
Yeah, you could use a service mesh. Yeah, that work. Well, the operator does not do the injection and things, so all the service mesh would need to be able to do the injection depending on the port, sorry, on the pods. But yes, in theory, you could use a service mesh and do full MTLS.
Great, thank you. And this is going to be our last question. What kind of security is added using certificates, public and private keys, data encryption, authentication, authorization?
So maybe to give it a bit of structure, yes, public-private keys and certificates have been used in twofold, actually, in the few things I showed. We use a server certificate which authenticates the MQTT server, the broker, to the client. So the clients know they talk to the right broker before exchanging information. So that is encryption and authentication. So you actually know that the broker you talk to is authentic. But we also use client certificates. So those have been sent from the clients to the broker, and they identify the individual clients to the broker. So the broker knows who is who, which adds authentication in the other direction. The thing I didn't get to, but I promise you it can do it, is then access control that is based on certain things and others don't. So that could be based on information on certificates or any other information.
Perfect. So are there any other questions? Okay, actually, does the showcase only include work with the license, or does it work with the HiveMQ CE version? Maggie, do you want to handle that one?
Sorry, can you please repeat that one? I'm sorry.
Does the showcase or the demonstration that Christian did only work with a license, or does it work with the HiveMQ CE version?
That is a good question. So, of course, you can also use HiveMQ in the community edition version with Kubernetes, but the Kubernetes operator, so the HiveMQ Kubernetes operator that Christian used for this demonstration here, works with the commercial version of HiveMQ, so the professional edition and the enterprise edition. But what you can do is, if you want to try it out, use our free trial of HiveMQ. So then you have the 25 connections that you see in the beginning of this webinar, and then you can try that out with the free trial of HiveMQ.
All right, any final questions? Okay, I'll give the people.
I just spotted, can it run on AWS? Yes, absolutely, it can run on AWS, certainly. And with the load balancers they have, it just works like with Azure. So.
Yep. All right. Well, I think we'll call it a wrap. So Christian, thank you very much for the great presentation and demonstration. And Maggie, you too. Thank you very much for the great presentation. So, and thank you everyone for attending. As I said, we'll follow up with an email to the recording of the webinar and a copy of this slide presentation. So thank you, everyone.